everyone, welcome back to my channel. In today's video, we will try to dive into key means clustering. And here's the objective of this lesson. Let's see, I will try to simplify this key means so you understand it 100%. So I will give you also numerical example step by step and plus the Python code. And I will try to select, let's say, not choose, let's say a real world, let's say example. So let's dive into key means. So key means clustering, it's unsupervised learning. So it's not like, let's say, submit to machine or any, let's say, decision tree or naive page. So this key means you have your data, but you don't have any class label. So your idea is here, it's to group all of these, let's say, data together. So it's as I said, it's unsupervised learning, and this means it's work with unlabeled data. So key means help you to find, let's say, patterns. It groups similar data points together, and these groups are called clusters. For instance, here we have this called cluster, and it helps. Let's see, for the real example, it helps the customer segmentation. It's divided the customer into different groups, and based on these groups, let's say you can add your discounts, you can give some offers, and etc. So it's also using for the image comparison, because it's somehow cluster the similar data, and just you don't need to repeat all of these data. And for the anomaly, of course, for the anomaly detection, assume that you have some images, and let's see, OK images, or maybe MRI images, and you would like now to cluster the similar images together. And if you have a defected image, then this image will be assigned, let's say, to another cluster. Okay, then let's just dive into the how it's working. So it's simple algorithm indeed. So first, we choose the select number of clusters. Let me zoom in. We need to select the key number of clusters. So this we have to do it manually, unfortunately. But there's by end of this video, I will try to show you how to choose the optimal key. Yeah, maybe as a note, because this talk, preparing this tutorial, it took much time. So please subscribe to my channel if you are not subscribed, and like this video. And also, if you have, of course, any question, drop it in the comment below. So as I said, starting with selecting the number of clusters, then the second step is initialize centroid randomly to the to the clusters, and assign point. Now the assigned point to the nearest centroid based on the distance, and recalculate this is iterative indeed. In the beginning, we have assigned two different, let's see, point into different to the clusters. Now we will calculate the distance to these clusters, or called centroid, and based on the distance, we will we assign the points to the clusters. Now we will also recalculate the centroids, and also do the assignment again. And if there's no changes, let's see, we can stop. And this is the final, let's see, result. If not, we will assign, not assign, we will recalculate the centroid and assign that again. And this is, I said, iterative way. So you can also stop when it's covered. I mean, no changes in the cluster assignment, or maybe you have number of iterations. Let's see, 100 iterations, or it depends on your needs. So let's have this example here. Assume that we have 6 customers here, and the annual income for this customer is 10,000, let's see, euros or dollars, and he is spending 30,000. Let's see, 30, spending a score out of 130. This is the spending score. Now we would like to to group all of these, let's see, these points into different clusters. So we have, let's see, 2 clusters here. So the idea is to cluster these customers into two different clusters. So in the beginning, as I said, we have randomly picked two initial centroid. Let's say, for instance, the first point here will be assigned to the first cluster, and the second point, not the second point, but this one here, 50 and 80, will be assigned to the cluster 2. So this called centroid. And if we have, let's see, many other data here, let's see, columns, this will be also, for instance, 10, 30, and 50, and 90, and depends on how many points how many features or columns do you have. So this will be extended, of course. Now, let's see, after assigning this, let's see, selecting the centroid of each cluster, now we will try to calculate the distance from each point here to this to each centroid, and we will see which one is the least distance. So for instance, I will calculate the distance even from the point to the same point, I mean for the same centroid, because this one in the beginning it's selected as a centroid. So you can see the distance from here to here, it's 0 0.0. You can use Euclidean distance here. So it means 10 minus 10, so 10 the first point, minus 10 the centroid, the first point in the centroid. It's 0 plus 30 minus 30, it will be also 0. So that's why we have here 0. And the distance, this point, the distance to the second cluster, it will be 10 minus 50 square plus 30 minus 80 square. So, and you can select the square root. So this will be, let's say, 64. And now we will select the minimum distance here. The minimum distance is C1. So this, in the beginning, it was assigned to cluster 1. But after calculating, this will be assigned to cluster 1. This, for instance, the cluster 2 and 1, and these are the 2 to the cluster 2. So we have this, for instance, the first assignment. Now we will calculate the mean of these points. So for instance, the mean of each points, let's see, find the new centroid by calculating the mean of these points. So for instance, in C1, cluster 1, I will try to calculate the mean of A and B. For instance, only A point and B points are assigned to cluster 1. So it means this point here, A and B. And sorry. And this is calculating the first point, the first point, the mean of the first point, and the mean of the second point. And now we have here the new centroid of the cluster 1. And here it's the C, calculating this, the C. Let me just maybe copy this data here. And we can have maybe better understanding. So we have C, D, E, F points from here. So we'll calculate this. You will calculate this, the mean of these points from 30 to 55, and again you will calculate the mean from 60 to 85. So that's why we have here the new centroid of the cluster 1. As I said, if we have many columns here, it will be the number of points here, or let's say the number of centroid. I mean, not centroid number. So here we have 2 points because we have only 2 columns. And again, we will use this centroid, the new centroid, and calculate again the distance for the whole data set. So again, we will calculate the distance from this point to the new centroid, and this point to the new centroid. And we will see there's no changes in the let's say assignment. So in this case, we can stop because it's already covered convergence. So, and this one way to stop after, let's say, no changes in the assignment, or maybe, as I said, after a certain time, a certain point of iteration. So this was, let's see, customer segmentation. So in this In this example, as you can see, for instance, cluster one, it's low income and low spending score. So it will be, let's say, called budget customers. And this one here, it's because we have it's a real, let's see, data set. This will be taken by the technical the stakeholder, let's say the name. And the cluster two, it's high income, high spending. So they are premium customers. So based on this, you can try to give some discount, or maybe let's see a top deal, let's see, for the customers. Depends on the customers. And for instance, for this customer, you can give better, let's see, deals. And for this, you can make some discounts. So we are talking now if it's, let's see, a website, or maybe even a customer in their banks. So now the good question here, or let's see, the important question is how to select the right key in key means. So because if you have a data and you don't need to try, let's see, randomly number of clusters. I mean, sometimes when you have your data, you can expect, or let's see, you have, let's see, insight how many keys you would like to cluster this data. But if you are not able to do this, there's an one method is called elbow method, which is most popular. There are many different methods, but this is the only one. Not the only one. This is the most popular. So I have only used this when I have some when I use the clustering. So what is this? It's like calculating the mean for each. Let me just calculating the mean, the the cluster, for instance, for with the first with the one cluster, let's see, and you will calculate this called within cluster sum of square, and this is the data point, and this is the centroid of the cluster, and this is number of clusters. And you can see here it's like selecting the elbow. So the optimal key, let's see, it's when there's no significant let's see, improvement. As you can see, from this point to this, there was a big drop, let's see. And from these points, the change is not, let's say, reduced, it's not significant. So we will see, we will choose this four number of cluster four. As you can see here, this is called elbow. And yeah, so K-means is a clustering that group the data based on the similarity. And by the way, you can use whatever you want for regarding the distance calculation. You can use cosine similarity. You can use Manhattan distance and others, and many others distance. And choosing the key, as we said, we have this is the best, let's say, uh, way to select the clusters. And let me just jump to the implementation. Okay, here's the main. So I have written this, let's see, with a pure Python, only with random and math, and this is with Skyline. So this one here is just for you, let's see, to make a debug and see how this is working. And if you would like just to use it and you don't need to understand any stuff here, you can just use the Skyline, because this is more optimized. And if you have real, let's see, real data, don't use this implementation. It's you have to use this because this is the more optimized, and also it's well known, let's see, package in Python. Okay, and that's it for today. Yeah, by the way, maybe you will have a different result if you implement this and this, because due to the randomness and yeah, because in the beginning, as you can see here, we see it select with the select random point cluster means, yeah, You can see it's selecting random data to the clusters as a centroid. That's why we have, let's say, different result here. But this is the main concept, and I'm quite sure that you will understand it, let's say, with this, with the numerical example and plus the Python implementation here. Okay, so if you like it, please subscribe into my channel, and that means a lot to me, and also make me keep me motivated. And if you have any questions, just drop it down in the comment below. Thanks for watching, and see you next time.